Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. You might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Okay, let's do some examples of using our first SUVAT equation. So a car accelerates from 0 meters per second to 25 meters per second in 10 seconds. What is the acceleration of the car? So as always, first things first, let's write out our equation. A equals V minus U over T, and then let's see which of those variables we can identify in the question. So first one, my final speed V is 25, and then my initial speed U is 0, and they've given me my T in seconds as well, 10. So I am first going to write out my equation with all of those in the correct spot. So I've got A is 25 minus 0, all divided by 10, and that gives me 2.5 meters per second squared. Okay, what if they don't ask me for the acceleration? What if they ask me the final speed of an object that accelerates at 5 meters per second squared for 5 seconds, and it starts with a speed of 4 meters per second? So again, just write down that equation first. A is V minus U divided by T. And then which pieces of information do I already have? So first there I have my A is equal to that 5 meters per second squared. And I also have the initial speed that they've given me is 4. So I write my U is equal to 4. And again, my time T they've given me equal to 5. So without doing anything yet, I'm going to put all of those into the correct places in my equation. So we have 5 is equal to V minus 4 divided by 5. And now I need to simplify this. So first thing to do is to get rid of that denominator and multiply both sides of my equation by 5. So I get 25 is equal to V minus 4. And you need to write all of these steps out in your exam. Then I can add my 4 to that 25 to give me V. 29 meters per second. Okay, now I want to find the initial speed of an object that this time decelerates at 5 meters per second squared for 20 seconds, and it says the object finishes at a speed of 2 meters per second. So again, let me write my equation out first. A is V minus U over T, and what variables do I have in my question? Okay, it's telling me that it decelerates at 5 meters per second squared. And I need to be careful here because I need to put, therefore, a minus sign in front of that 5 for my acceleration to show that it's a deceleration. And then I can also identify that my time here is equal to 20 seconds. And I've also been given that information that my final speed is 2 meters per second. So again, those 3 pieces of information, I'm going to plug them into the right parts of my equation. So I have minus 5 is 2 minus U over 20. Time to get rid of that denominator. So if I multiply both sides by 20, I get minus 100 is 2 minus U. And then, okay, what I'm going to do is I'm going to bring that U over to the left-hand side and bring that 100 over to my right-hand side. So that I have U is equal to 2 plus 100, 102 meters per second. Okay, then I need to practice using that second SUVAT equation. V squared minus U squared is 2AS. So in this question here, we have the final speed of an object I'm trying to find that accelerates at 4 meters per second squared for a distance of 50 meters, and the initial speed of the object is 3 meters per second. So before doing anything, write out my equation. v squared minus u squared is 2as. And then what can I identify? Okay, I've got my acceleration there as my 4 meters per second squared. And I also have my distance there, which remember is my s in my equation of 50. They've also given me my initial speed u of 3 meters per second. Okay, time to just put those into the correct parts of my equation. V squared minus 3 squared is 2 times 4 times 50. And first, I am going to look at my right-hand side of the equation, multiply all those numbers together. And on my left-hand side of the equation, I'm just going to simplify that 3 squared so it just says 9. So v squared minus 9 is 400. Then to get that v squared alone, I need to plus 9 to both sides. And then to get it as v, I just need to square root that 409. So that is 20.2 meters per second. Okay, and the next example is to find the acceleration of an object that goes from 10 meters per second to 4 meters per second in a distance of 10 meters. So my equation first, v squared minus u squared is 2as. And then this time I've been given u from 10, so that's my initial one, and then to 4, so that must be my final speed, and my distance is 10. So again, let me put those into the correct positions. 4 squared minus 10 squared is 2 times a times 10. Okay, now let's look at my left-hand side of the equation. So I'm going to simplify that. So I've got 4 squared is 16 minus, well, 10 squared is 100, okay, is equal to 2 times a times 10. Or in other words, minus 84 equals 2 times a times 10. Now to get that a alone, I need to divide both sides of my equation by 2 times 10. So I have minus 84 divided by 2 times 10 equals a. And that gives me minus 4.2 meters per second squared. So that minus sign you see there just popped out of just using my equation. And that makes sense because this object went from a faster speed 10 to a slower speed 4. So it's decelerating. Okay, and final example using this equation. Find the initial speed of an object that accelerates at 4 meters per second squared for a distance of 30 meters. The final speed of the object is 60 meters per second. So let me get my equation. V squared minus u squared is 2as. And what piece of information can I identify? Well, first I've got v is 60 there, my final speed of my object. I've got a there, and that is equal to 4. And they have also given me s, which is equal to 30 meters. So let me put those into the right spots in my equation. 60 squared minus u squared is 2 times 4 times 30. Okay, and then I'm going to simplify that right-hand side by just multiplying all those numbers together. And I'm going to simplify my left-hand side by squaring that 60. So I have 3,600 minus u squared is 240. So I'm going to plus my u squared over to the right-hand side. And I'm going to move my 240 over to the left-hand side by taking it away. So I have 3,600 minus 240 is u squared, which gives me 3,360 is u squared. And therefore, if I square root that, I get 58 meters per second. Okay, and now we're going to use one of our SUVAT equations, but in a slightly different context. So we have, what is the final speed of a ball, which has been dropped for 5 seconds, air resistance is negligible. So I'm looking for v, my final speed, and the piece of information I've got in my question readily available to me is my time t is equal to 5. But then I'm feeling a bit stuck and I might be thinking, well, I don't have enough information to answer this question. However, I have some hidden bits of information within this question. Firstly, it tells me that my ball has been dropped. Since I'm dropping my ball, then the initial speed of my ball must be 0 meters per second. So that's an extra piece of information that I have. And then I'm dropping my ball and air resistance is negligible. So the only force acting on my ball is its weight, pulling it down. So it must be accelerating just due to gravity, and we should know that that means its acceleration would be 10 meters per second squared. Okay, that's one of the things that we have to learn for our GCSE. So I'm going to use my first CVAT equation. A equals V minus U over T, and let me put them all in the correct place in my equation. 10 is V minus 0 divided by 5. Now I need to multiply both sides by 5 so that I get 50 was equal to my V minus 0. So 50 is equal to V meters per second. Before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not? Okay, my tips and tricks for this section. So the first one is writing out variables / formatting your answer. So for this one, I would always, if it's a SUVAT question, write out SUVAT, and then I can say, do I have S, do I have U, do I have V, A, and T? And if I do have them in the question, I can write S equals U equals V, A, T. This is really helpful because it will help you to choose which SUVAT equation you should be using. If in your question you have S, U, V, and A as your variables, okay, remember one of them will be the thing that you're looking for, then you use the second equation, V squared minus U squared is 2AS. But if you have U, V, A, and T as your question, then you use A as V minus U over T. The next tip is what we just did in our previous example, which is these hidden variables. If it says at rest, that's 0 meters per second. If it says it comes to a stop, then your final speed would be 0 meters per second. If it's accelerating under gravity, your acceleration should be 10. Okay, and finally, if you find it hard to remember what's S, U, V, A, and T, at least for my U and my V, these are both speeds, so very easy to get mixed up. You can think, well, U comes before V in the alphabet, so U is my initial speed and V is my final speed.